Well, hello and welcome to the first in a series of videos on calculus topics, the first of which is solving problems using the definition of the derivative. Now I put this little pause button here to indicate that as I'm going through the problems, you feel free to hit the pause button and then come back, work the problem on your own and come back and check the solution. Or you can just watch the problem as I work through it. Okay, first of all, the definition of the derivative. So if we have some function, and it doesn't have to necessarily look like this, but some function f of x, let's say it looks kind of like that. There's x, and there's the function evaluated at x, also called the y. If I take some function and evaluate it at some point f of x, or some point there x, where the y coordinate is f of x, and then I go a little bit further on, let's say that's your x, and let's say I go over a little bit more and a distance of h. That would make this x plus h, and then up here would be f of x plus h. If I want to know the average rate of change between these 2 points, I would take the change in y over the change in x. So the change in y is going to be f of x plus h minus f of x, the two y coordinates, and the change in x is going to be x plus h just minus x. So this is the average rate of change. Now if we take the limit of h and we shrink it down to 0, then that average rate of change becomes the derivative. So we're going to use a definition of derivative to find the derivative of each of these functions with respect to x. Alright, so I'm going to write this as f of x equals negative 2x plus 5. And then going back to that previous screen there, I'm going to use that definition of the derivative. Now we'll write it up here. It's the limit as h goes to 0 of f of x plus h minus f of x over h. So f of x plus h means just substitute x plus h in place of the x. So this becomes negative 2x plus h plus 5. And that's going to be negative 2x minus 2h plus 5. And then my f of x is just what I started with. So let's put that all together. Okay, so I've brought our formula a little bit closer to what we're working with here. So I'm going to plug back in what I have. This now becomes negative 2x minus 2h plus 5 minus negative 2x plus 5 all over h. And that's the limit as h goes to 0. Now I can't plug in the 0 for h yet, because then it's going to give me an indeterminate form, or it's going to give me no solution because it's 0 in the denominator. But watch what happens next. I've got negative 2x minus a negative 2x. That cancels. I've got negative 2h and no other h's. And then I've got a 5 minus a 5. So I'm left with negative 2h over h. The h's cancel, and then my answer is just negative 2. Let's do another one. So now I'm going to work with problem number 2. Now I've got limit as h goes to 0, and f of x plus h is going to be negative 4 times x plus h minus 2, and then minus a negative 4x minus 2 over h. So this becomes negative 4x minus 4h minus 2 plus 4x plus 2 over h. Our 4x's go away, our 2's go away. We have negative 4h over h, so the derivative is negative 4. Okay, so let's do it again here. We're going to use f of x is 4x squared plus 1, so f prime of x, the derivative, is going to be the limit h goes to 0 of f of x plus h. So this would be x plus h squared plus 1 minus 4x squared plus 1 over h. And that equals, and we got 4, and this is going to be x squared plus 2xh plus h squared plus 1 minus 4x squared minus 1. And multiply the 4 by each one of these, and that's all over h. And I get 4x squared plus 8xh plus 4h squared plus 1 minus 4x squared minus 1. So the plus 1 and the minus 1 go away. The 4x squared and the minus 4x squared go away. And so I'm left with 8xh plus 4h squared over h. I divide h into the top and bottom. I end up with 8x plus 4h. And now as h goes to 0, that goes away, so my answer is just 8x. Let me just say, though, if you are interested in one-on-one tutoring services, please visit my website. You can also get a free download of 5 strategies for overcoming test anxiety there. So thanks for watching. See you in the next video.